Science fam, we're back looking at number 3 for our intro mole-to-mole problems. It says if we have 8 moles of water that's formed in a reaction, we want to know, question mark, how many moles of carbon dioxide would have formed as well. So if we look, we really want to say that if we have 8 moles of water, how many moles of carbon dioxide would be formed as well? Well, let's think about that. There's a relationship between water and carbon dioxide. For every 4 moles of water, H2O, there is going to be 3 moles of carbon dioxide. So what we're going to do is take advantage of those big numbers, the coefficients, to help us get a ratio. So what I'm going to do is start with what I have. I have 1 mole of water. Now I want to get rid of moles of water and convert to moles of carbon dioxide. So to do that, I'm going to need moles of water on the bottom so that my water cancels out. And we're going to put on top what it is I'm solving for, which is moles of CO2. So notice by doing that, now I have moles of water on top and bottom. They'll be able to cancel out. The only thing left to do now is use the numbers from the balanced equation. There's 4 moles of H2O for every 3 moles of CO2. And the reason this type of problem works is because moles of H2O units cancel out, and you're left with moles of CO2 for your units. So just depending on what you start with, that's what you end up putting on the bottom, the denominator, to cancel out. So this ends up being 8 times the top number, which is 3, divided by 4. 8 times 3 is 24. 24 divided by 4 is going to be 6. So 6 moles of CO2. Let's take a look at number 4. If I have 20 moles of propane, right? That's kind of like my A, what I'm starting with. I want to know how many grams of CO2 would be formed. Now, wait, we've been doing mole to mole, but now it wants us to go to grams of CO2. So here's what we're going to need to do. We're going to need to go from moles of propane, and from there, we're going to do what we've been doing on this worksheet. We're going to convert to moles of carbon dioxide, CO2, and then once we're in moles of carbon dioxide, we can use our mole map to go to grams of carbon dioxide. So let's try that one out and see how that goes. So let's start with what we're given. We're given 20 moles of propane. So 20 moles of propane. Propane, by the way, up the balanced equation at top is C3H8. From there, remember, I want to get rid of moles of propane, C3H8, and I want to get to moles of CO2, right? So the reason that I put moles of C3H8 on the bottom is so that it cancels out. Now that I have that, all I have to do is look on my table, my balanced equation up here, and see next to CO2, the coefficient is a 3, so I'm going to put a 3 there. And next to propane, the coefficient is a 1, so I'm going to put a 1 there. Now, that would have been it, going from moles of propane over to moles of CO2, but we have one more step now. We want to go from moles of CO2 to grams of CO2. If you look on your mole map, we know then that if you're going to go from mole island to mass island, you've got to put moles on the bottom of what you have, and then the molar mass, or grams, on top of what you're looking for. So in this case, according to our mole map, we're going to use 1 mole of CO2, and then I'm going to look on the periodic table for my molar mass, 1 carbon plus 2 oxygens. And what I end up getting when I add that up is about 44.01 grams. And now that I have that, let me make room for my answer. I'm going to plug that into my calculator. So let's do that. It's going to be 20 times 3 divided by 1 times 44.01 divided by 1. Remember, you always multiply by the top, divide by the bottom. But what you end up getting is 2,640.6 grams of carbon dioxide. So do you see what happened there? What we had to do, we used our previous knowledge of the mole map to convert from one completely different compound, propane. We converted it into moles of another compound, carbon dioxide, and then we converted the moles of the carbon dioxide into its mass. So now we have the power of converting back and forth between different compounds, all because of our balanced equation. That's incredible. But now if we jump over to the next one, number 5, we have 20 grams of propane. So that means we have a mass of an object to start with. So I'm going to call that the mass of object A. And I want to know, and by the way, this is a typo, this should be moles. How many moles of CO2? So I'm looking for moles of B there. Sorry about that typo, but it should be right on your paper, right? Would be produced. So that's the question. All right, so to do that, let's start with what we have. We have 20 grams of propane, which is C3H8. Now, if I want to eventually go from mass A to moles of B, I'm going to need to go mass A and convert to moles of A, and then go from moles of A to moles of B. How? Because we know that we can use our balanced equation to go from moles of one thing to moles of another. But before we do that, we've got to get rid of our mass. So that's our first step. So I'm going to go and use my old mole map, and I can go from mass A to mole A. To do that, I'm going to put the mass on the bottom, right? The molar mass, C3H8 on the bottom, and moles of C3H8 on top. According to my mole map, let me change my color here. It's getting a little tight. Got 1 on there. And then, of course, on the bottom, I need to find the molar mass of C3H8. So 3 carbons plus 8 hydrogens. All right, after looking, the mass will be 44.11 grams on the bottom. Now that we did that, grams of C3H8 cancel. But now I'm left with moles of C3H8. Now that I have moles of C3H8, I want to get rid of that, so I'm going to cancel it out by putting C3H8 moles on the bottom. And I want to get to moles of CO2, so I'm going to put that on top. Now when you go mole to mole ratio, where do you go? Right to the balanced equation. So propane's moles is 1, carbon dioxide's moles is 3. So when we put that together, take a look, everything is going to cancel out. Propane cancel out. And what we end up getting is 20 times 1 divided by 44.11 times 3 divided by 1. Throw that all together and I got about 1.36 moles of CO2. Now, if you had trouble following that, especially this first part, that's because you might not be really remembering and understanding your mole map. So again, take a look when you go from mass island to mole island, treat these like 2 separate problems. So this first step was going from mass island to mole island. Then once you got that answer in moles, we then been doing the conversions like we did over here up at the top, where you're just taking a mole to mole conversion by simply using your big coefficients from the balanced equation. All right, let's keep moving forward, but nice job, science fam. Hang in there. We're going to get this, but this really is building off of previous knowledge. So if you are struggling with the previous knowledge and canceling out units in that, you need to go back and practice a little bit more. Okay, take care. Be well.